Today we're going to work on multiplying decimals with the area model and the traditional method. As we talked about in class, the area model is a tool for developing understanding of decimal multiplication, and it's an efficient method for finding a product for simple decimals in particular. Because we reviewed in class the reading on this side of the page and this side of the page, and we also went through these examples, I'm going to focus on going through the practice your skills on the following pages. So if you go to the following page, in addition to the examples at the top of the page, there's again the little practice your skill symbol that you should be looking for every time you have a notecatcher. In this practice your skill, we're completing the area model to find the product of 3 times 5 and 4/10. So as you can see to the left, there's a model set up, but just in case you're not clear where that came from, I'm going to recreate that process. When you have the use of an area model to find a product, in this case, since we just have the whole number 3, we don't need to do any divisions of our rectangle. But for 5 and 4/10, we're going to put the ones place there and the 4/10 there. And that's what this diagram is showing you. Then you do traditional multiplication with the numbers. So 3 times 5 is 15. And what we worked on in class today is using mental math skills to do 3 times 4/10. We know 3 times 4 is 12. But 3 times 4/10 is like 3 sets of 4/10, which is also the same as 4 dimes or 40 cents 3 times. And we know when we add up 40 cents 3 times, we would get $1.20. So with mental math, we want to focus on doing 3 times 4 and putting in 12 and identifying the fact that there's one digit after the decimal. So we're going to move in and we're going to change that 12 to a 1.2. So that's what goes in this area model on your notecatcher. And then looking at the boxes over here, you're asked to complete the box. So it's 15 plus 1.2. And altogether that's 16 and 2/10. And that's your final answer. So if you skip down to problem 3, the other thing you're asked to do is use the traditional method to check your work to problem 1, because we value both methods, and in 6th grade we find both methods are equally important. So whenever I set up a problem like that, I put the number with the most digits on the top when I stack. That's my personal preference. I find that it's helpful for most people. So 3 times 4 is 12. I'm going to carry the 1. 3 times 5 is 15. And I have to add 1, which is 16. I have one digit in the problem after the decimals, which means I have to move in from the outside and put my decimal. So my final answer is 16.2. And it checks with my area model answer. That's a great place to use an area model because it's a simple decimal multiplication problem. Practice your skill number 2 is a little more complicated, but for many students, it's also a useful tool. So again, I've set the problem up, and I'm going to review how I did that off to the side. So I have 5 times 5.6, so since it's 5 and 6/10, I'm going to make a division in my box, times 4 and 5/10. And then explain where this diagram came from. I used traditional multiplication. 4 times 5 is 20. 4 times 6 is 24, but 4 times 6/10 is like 4 sets of 60 cents, which is $2.40. So again, if there's one digit in the problem after the decimal, which is right here, then you need to have in your box here, you start with your decimal outside of the number and you move in. That's where that came from. The goal is to do this with mental math, to be very fluid as time goes on. 5 times 5 is 25. 5 times 5/10 is 2.5. Because it's like 5 sets of 50 cents. And finally, you could also think of it, since 5.5 is 1/2, it's like saying half of $5 is $2.50. And then the last part is 5/10 times 6/10. So 5 times 6 is 30. But now we have 2 decimals, 2 digits after the decimal. So we're going to come in twice, and we're going to put our decimal there. So in this area model over here, the missing values are 2.5, we're going to write that here, and 3/10. When you add all of those up, again, you want to focus on mental math if you can. 2.4 plus 2.5 is equal to 4.9. So you could at least do some of that addition in your head. You have 20 plus the 4.9 right here. That's 24.9 plus 0.3, or 3/10. And remember from yesterday, when we add decimals, we line up the decimal place, and we end up with 25 and 2/10. If you look down here on problem 4, you're asked to practice the skill with the traditional algorithm, which is the stacking method. 4.5 times 5.6. 6 times 5 is 30. Carry the 3. 6 times 4 is 24. Plus 3 is 27. Then you need your placeholder. You continue the problem. 5 times 5 is 25. Carry the 2. 5 times 4 is 20, plus 2 is 22. Now we add. 7 plus 5 is 12. Carry the 1. 2 plus 2 plus 1 is 5. Go back to the problem and count how many digits are after the decimals. There's 2. Move the decimal in. Your final answer is 25.2. It checks. So I know I've done my work right. On the following page, when you read the directions, you can use any method. I'm going to model both methods and leave the rest of the worksheet to another day in class. So for the first problem here, I'm going to use the traditional method. I'm going to stack my numbers. But before I do that, I'm going to follow the directions and do an estimate. So an estimate for me would just be something really quick that I think of in my head, like maybe 6 times 4. So that's an overestimate, but it helps me remember that my answer's going to be not in the hundreds, and probably not in the numbers less than 15. So now I'm going to begin my problem. 7 times 8 is 56. carry the 5. 8 times 5 is 40, plus 5 is 45. Put my placeholder in, and continue the problem. 3 times 7 is 21. Switch colors here. Carry the 2. 3 times 5 is 15, plus 2 is 17. Add. 4 plus 7 is 11. Carry. And then look at the original problem. There's 2 digits after the decimal. So that means I have to go in twice and put my decimal here. I think that my answer should be 21.66. Another way to check your work with a calculator. Remember never to check your work with a calculator until you've actually finished the problem without the calculator. 21.66. It checks out. So I'm going to move on. Put my calculator away. On problem 6, I'm going to use the area model because if you remember on the previous page, the area model is especially useful when you have simple decimals. That's when it's especially useful. It maybe isn't useful all the time. But for this problem, it's very useful for me because the decimals are very simple. First, I'm going to estimate. I'm going to say this is about 5 times 200. So 5 times 200, if I count in my head, 200, 400, 600, 800, 1,000, my estimate is 1,000. And I know that that's an over estimate. But that gives me an idea of what my answer should be. What I like about this is I'm going to put my 4.5 here and my 200 here. 4 times 200 is 800. And 0.5 times 200 is the same as half of 200, which is 100. So my final answer is 900. Again, I can check with the calculator. It's a good strategy. 200 times 4.5 is 900. So my final answer is 900, and it checks. On your work tonight, you can use either method unless you're given specific directions to follow a particular method.